Hello everyone. Today I'm going to be talking about chapter 2.1, which is derivatives and rates of change. So here's a really funny story. I did a recording of all of this and my mic was off the whole time. So I'll make the video kind of quick and just just explain everything. And then we'll do some practice problems. Yeah, that's fun. Yeah, okay. So, our first section is tangents. And if you remember what a tangent is, let's just say this is our circle. From geometry, you learn that it's a line where it touches a point on that circle at one point. So let's say you're given the points P and Q. And this should be, for right now, it would be x and f of x. And this would be just x. So, if we consider our slope between P and Q, that's going to be this right here. F of x minus f of a divided by x minus a. Now, why are we considering our slope to get our tangent? Is because as you move Q, your point Q closer and closer, our tangent looks like that. And as it gets infinitely close to P, it would just be our tangent at point P, which is why we use the subject of limits. So now, for my example, I did y equals x squared, and find the tangent line at the point 1, 1. So you have a equals 1, f of x equals x squared, and f of a equals 1. So using this is f of x, that's f of a, x minus a. You factor the top, and x minus 1 cancels, so you're left over with x plus 1, you get 2. And now since you want the line, you have to use your, what is this called? I don't remember, but your formula for a line. And since this shows the slope, I should write equals m. Since that shows the slope, our m would be whatever we found here. What did I do next? Oh, okay. There's another definition of a tangent or a slope at a point, which is where the distance, you're considering the distance between the 2 points as h, where this is a plus h, and this is a plus h comma f of a plus h, and you get this formula. The limit as x approaches h, x should be x. Whoa. As h approaches 0 of f of a plus h minus f of a divided by h. So now let's do this problem right here to do that. So given y equals 3 divided by x, find the tangent line. Oh, I never did that. But find the tangent line at the point 3, 1. So now, I'm yawning, sorry. So a is 3, so then f of a, which would be 3 plus h minus f of 3 divided by h. F of 3 is 1, so that's why it's minus 1. Why is there arrow? Oh, I know why. I remember. And then this would be 3 over 3 plus h. Now to get it under one denominator, multiply that by that, that by that, and then you get 3 minus 3 plus h divided by 3 plus h divided by h. You get this, you get that. Okay, so that would be our m, so m equals 1 over 3. And now you need to find the line. So y minus 1 equals our m, times x minus that. You can write it like that, or the other way, which would just be to make it y equals whatever. But just for you, I'll do it. So it would be 1/3 x. That would be minus 1. That would be plus 1. So it's just 1/3 x. Right? I'm really bad at arithmetic. It looks right. Okay. What's the next topic? Oh, velocities. So we define average velocity as our displacement over time, which is the same as our formula that we found here. There's a lot of circles, but yeah. This means our instantaneous velocity, which would just be our velocity at some a or time, would be this, which you should already know. Now, this example was, let's say you have a ball that you're dropping from a 450 meter tower. Our function for displacement would be this. So now we want to find our velocity at time equals 5. So then you just plug everything into that formula. So for now, let's say a equals t, and we just use a instead of dealing with all the numbers right now. So using the formula, you get 4.9 times a plus h squared minus 4.9a squared divided by h. You expand everything, you get rid of some terms. This is 2a h plus h divided by h. Wait. Yeah, 2ah plus h squared divided by h. These h's cancel, and this remains with h. So you get 4.9 2a. And now you're finding it at time t, so you just plug in 9.8 times 5, which is 94 meters per second. And now, let's say you're trying to find the velocity as it hits the ground. So you just let our displacement function equal 450 equals 4.9 t squared, and you get t equals 3.6, or 9.6, and then you just plug that back into 9.8a. Our next topic or section is about derivatives. So again, it's the same two formulas, but this time you're given this special notation which represents your derivative at some a. So the difference between f of x and f prime of x is that prime, which just tells you your rate of change. Well, you don't know what that is yet. This function tells you the slope at any point on the graph. We'll get more into that in our next unit, but yeah, they're not equal because of that, the prime. Yeah, okay, same two formulas, and now this is just another example of those two formulas. Find the derivative of this function at these two values. I only did this one because I'm lazy. But anyways, you could just look at what I did. You want to find that. You plug everything in. You get rid of some terms. You get this. And then you get -4. Next thing we have to talk about is rates of change, which first we get delta x equals x1 minus x0, and delta y is f of x1 minus f of x0. And this also means our slope is going to be delta y over delta x, which is this, which is also your slope. Wait, I just said that. I'm sorry. But yeah, that's our slope. And our instantaneous rate of change is the limit as delta x approaches 0 of your delta quotient, or the limit as x1 approaches x naught of that. So let me look for some practice problems now. Oh yeah, holy handwriting. Okay. What to choose? I don't know. There's not much to choose here. I can do that. Okay, we'll do 2 problems. Our first problem is going to be to find f prime of a when you have the function f of x. Do I want to do this one? Yeah, that's okay. F of x equals x cubed minus 3x. So I like using this formula because I'm just used to it. Not x. A over h. So now you get the limit as h approaches 0 of a plus h cubed minus 3 times a plus h minus f of a, which is going to be a cubed plus 3a, all divided by h. I just realized I have to do that, which is okay. Wait, I don't remember how to do that. Wait, what's... I don't remember. Okay, I'll do it manually. I'll do it in the red, just for that. It'll be a plus h times a squared plus 2a squared, 2ah, 2ah plus h squared minus 3a plus minus, I can't write, 3h minus a cubed plus 3a. That's nice, because then these two go away. So now you have the limit. I don't know why I changed color actually. The limit as h approaches 0 of, now doing this thing, get a cubed plus 2a squared h plus, oh wait, I just remembered how to do it. Oh my god. You get this, 3h squared plus 3ah squared plus h cubed. I just remembered that. And that goes away, so you get minus 3h minus a cubed over ha, and then you get the limit as h approaches 0. These two go away. What's left? You have minus 3h. I changed color again, but you know, too bad. Minus 3h, yeah, that makes sense, plus 3a squared h plus 3ah squared plus h over 3 over x, and you get the limit as h approaches 0 of factor h out, or cancel h out. You get minus 3 plus 3a squared, I'm sleepy, plus 3ah plus h squared. Plug in 0 for h, you get 3a squared minus 3. And this means for whatever a, this will tell you the slope at any a, any a you choose, or any value on the function. So if you have a function, if you have a function, and let's say when a is like 2, that will show you the slope at this point. When a is 1, it will show you the slope at this point. That's what this does. Okay, last problem. Wait, where was it? Now on this. Yeah, sure. Okay. So you're given the cost in dollars of producing X units of a certain commodity is C of, where am I? Is C of X, the cost of X equals 5,000 plus 10X plus 0.05X squared. This is the first find our average rate of change from, X equals 100 to X equals 105, and then from X equals 101. And looking at rates of change, our average rate of change is just this. So then this would just be f of 105 minus f of 100 divided by 105 minus 100, which is 5. For 100 to 105. And now for 100 to 101, it would just be f of 101 minus f of 100. 101 minus 100 is 1, so it's just that. And that's our average rate of change. Oh wait, it's not cost per cost, it's just how much. Okay, that's your average, like how much of a product you're building on average with how much, per, I don't know, it's just your average rate of change of your units, of how much you're making. Okay, now you're asked for your instantaneous rate of change of C with respect to X when X equals 100. There's something on my screen. Okay, so that's just the limit as h approaches 0 of f of a equals 100, so 100 plus h minus f of 100 divided by h. Oh, watch, I'll do this with no calculator, because sometimes I got tests like this with no calculator and it was horrible. Okay, so f of 100, 5,000 plus 1,000, 6,000, 10,000 times 0.5. Wait, 10, 100, 1,000, 10,000. This one's right there. Okay, so 6,555, I think. So the limit as h approaches 0 of minus 6,555 divided by h. Maybe I won't do this. That looks... Oh, that's busy work. Okay, but you get the idea. And then you just find f of 100 plus h. So that would be like 5,000 plus 10 times 100 plus h plus 0.05 to 100 plus h squared. Okay, you get the idea. And then you just solve it. And that tells you how much Wait, I don't understand the question. That tells you, oh, it is cost. That tells you the cost for making 100 products, basically. And this tells you on average how much it costs to make 100 to 105. And this is 100 to 101. And you will notice that 100 to 105 is greater than 101 to, or 100 to 101 to instantaneous. Because it's similar to this, where this is going to, let's just say, this is our 105, 101, and instantaneous. You're getting closer and closer to 100, so then it would make sense that 105 would be farther away, and as you get closer, it gets closer to that. Okay, that's it. Thank you for watching.